HVAC temperature rise testing uses a simple formula. CFM equals the heater wattage divided by the product of the specific heat of air, the air density factor, and the measured temperature rise, so precise temperature sensing is critical for accurate airflow measurement. For accurate airflow CFM using the temperature rise method, start by measuring heater wattage and the temperature difference between supply air leaving the heater and return or room air entering the system. Use the formula CFM equals heater wattage divided by 1,205 times temperature rise, where 1,205 represents the product of air properties in consistent units, and ensure all values use the same unit system. Use bead-type thermistors or fine-gauge thermocouples for sensor elements because their small thermal mass provides rapid response, minimal self-heating, and a small physical profile that disturbs flow very little. Avoid larger diameter sensors, infrared sensors that read radiant heat, and sensors mounted near strip heaters or heating elements because those sources bias readings high and invalidate the temperature rise. When inserting probes, place the sensing junction fully in the airstream center or in a well-defined representative position for the duct or register. Secure the probe so it does not contact metal surfaces or the heater, and so the wire path does not conduct heat into the sensor. Calibrate sensors against a reference at expected test temperatures and perform a 2-point check at a known cooler and warmer temperature to verify linearity, document calibration offsets, and adjust readings if necessary. Finally, average several rapid successive readings after steady-state operation has been established rather than relying on a single instant value to reduce noise and transient errors. Common mistakes include using slow, bulkier sensors that average transient fluctuations and understate the true peak temperature rise. Fix this by switching to Bead-Thermistors or fine-gauge thermocouples with known response times. Another frequent issue is placing the probe too close to the heater or duct wall where radiant heat or conduction skews results. Correct placement by centering the junction in the airflow and securing it away from reflective surfaces. A third problem is failing to verify sensor calibration and assuming factory accuracy. Resolve this by performing a field 2-point calibration against an ice water reference and a warm bath or calibrated standard thermometer and log corrections applied. BigHomeProjects.com connects homeowners with local HVAC contractors and provides tools and articles that explain test methods and sensor selection to help homeowners evaluate bids and results. Contractors use the platform to find local jobs and showcase verified expertise in airflow testing and proper measurement practices.